Let t represent the time it takes them to complete the job working together. Now, what part of the job can Brian do in t hours? Well, he can do the whole job in 8 hours. So if it takes them 1 hour working together, he can do 1/8 of the job in that 1 hour. If it takes them 2 hours, he can do 2/8 of the job. If it took them 8 hours, he could do 8/8 of the job, or the whole job by himself. So in t hours, Brian can do t/8 of the job, and Armando can do t/6 of the job in a similar fashion. And we want to know what t is so that t/8 plus t/6 adds up to one complete job. It's not going to be 8 hours because in 8 hours, Brian can do it by himself. It's not going to be 6 hours. It's going to be smaller than 6 hours because Armando can do the whole job by himself in 6 hours. So we're going to multiply through by 24, which is the least common denominator, using ideas that we've learned previously. Here the 24 and the 8 cancel, and we have 3t. Here the 24 and 6 cancel, and we have 4t. And here we get 24. So we have 7t equals 24. T equals 24/7 hours. That's an acceptable answer, but dividing 7 into 24, it goes in 3 times with the remainder of 3. So that's 3 3/7 hours, which tells us it's just about exactly 3.5 hours, just a slight bit less than 3.5 hours. Either of these answers is good, and we're done. Let t represent the amount of time it takes the pipe and the hose working together to fill the pool. The pipe alone can do it in 12 hours, so in the t hours they work together, it can do t/12 of the job of filling the pool. And in those t hours, the hose alone can do t/30 of the pool. And together we want to know what time will give us one complete job. Well, again, we're going to multiply through by the least common denominator, which in this case is 60. And it clears the denominators, so we get 60. 1 times 60 is 60. 60 over 30 cancels to 2. 60 over 12 cancels to 5. So we have 7t equals 60. Divide both sides by 7. And we get the time is 60/7 hours. 7 goes into 68 times with the remainder of 4. So 8 4/7 hours, just a smidgen over 8.5 hours, is the correct answer. Let's let x represent the speed of Sean's kayak in still water. Then when he's going downstream, he's going that speed, x, but then you also add in the speed of the water, which is 3, so he's going x plus 3. When he's going upstream, he's doing his x, but it's x minus 3 because he's heading into the power of the water. Now, if you solve rate times distance, rate times time equals distance for time, you get time equals distance divided by rate. So in time we can put distance divided by rate. Distance divided by rate. Speed. And now it says these two times are equal. They're equal. It's the same time. So we have 4 over x minus 3 equals 10 over x plus 3. Multiplying both sides by the least common denominator of x minus 3 times x plus 3. Here the x minus 3's cancel, we get 4 times x plus 3. Here the x plus 3's cancel, and we get 10 times x minus 3. So we have 4x plus 12 equals 10x minus 30. Subtracting 4x from both sides brings the x's over here, adding 30 to both sides. Brings the numbers over here, dividing both sides by 6 gives us x equals 7. So it looks like the speed of Sean's kayak in still water is 7 miles per hour. We could check that out and see what it means, but I think if you check it out by putting 7s in for x, you're going to find out that he's only going for 1 hour. And that makes the numbers work out pretty simply. So I think you can check that on your own. In this problem, we're going to set up a proportion, and proportions are one of the most useful pieces of practical mathematics that there is. So you've got a sample of 220 bulbs total. And out of that sample, there are 8 defective. So there's 8 defective out of 220 total. And we want to answer a question with that information. How many defective bulbs would you expect out of 1,430 total? Note when we set up a proportion, if it's defective divided by total on the left, it most likely should be defective divided by total on the right. So we're expecting a smaller number than this, but one that's proportional to 8 over 220. So then the question is, how do we solve this? And we could multiply both sides by the least common denominator, but it's kind of hard to find the least common denominator. So instead, I'm going to cross multiply 220 times x equals 8 times 1,430. I'm not going to worry about that 8 times that. I'm going to divide both sides by 220 first. So now I have x equals 8 times 1,430 over 220. 10 goes into this 22 times, 10 goes into this 143 times. 11 goes into this twice, 11 goes into this 13 times. Looks like 2 goes into this once, 2 goes into this 4 times. So I'm getting 4 times 13, which is kind of the number of cards in a deck of cards. So it's 52. Of course, it would be possible to grab a calculator and just do 8 times 1,430 divided by 220. But the answer is you'd expect 52 defective bulbs. Done.